This is SpaceTime Series 24, Episode 122, for broadcast on the 27th of October 2021. Coming up on SpaceTime, problems as NASA's Lucy mission launches to study Jupiter's Trojan asteroids, a new study claims Venus could never have had oceans, and Beijing launches 3 taikonauts on a mission to set a new Chinese space endurance record. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Lucy mission managers are still trying to determine the full extent of the problem with the spacecraft after one of the solar arrays failed to deploy properly shortly after launch. Telemetry from the 1,500-kilogram probe suggests that only one of the 2 solar arrays fully unfurled and latched, the second array only partially opening and failing to lock into place. Lucy, NASA's first mission to study Jupiter's Trojan asteroids, blasted off aboard a United Launch Alliance Atlas V 401 rocket from Space Launch Complex 41 at the Cape Canaveral Space Force Station in Florida.
Status check. Go Atlas.
Go Centaur.
Go Lucy.
7, 6, 5, 4, 3, 2, 1, 0. Liftoff. Atlas V takes flight, sending Lucy to uncover the fossils of our solar system.
Tower clear. RD-180 propellant utilization has gone to closed loop control. The vehicle has begun the pitch yaw roll maneuver. Now, 30 seconds into flight, vehicle is 0.6 miles in altitude, traveling at 939 miles per hour. RD-180 performance continues to look good at this time. Engine pump speeds and injector pressures are in family for this thrust level. Atlas vehicle attitude remains stable at this time. Attitude rates near zero in all axes. Now at T plus 70 seconds into flight, vehicle is 4 miles in altitude, 0.2 miles downrange distance, traveling at 1,200 miles per hour. Mach 1, Atlas is now supersonic. Vehicle is now passing through max Q, maximum dynamic pressure. RD-180 engine parameters continue to look nominal after the prior adjustment to the thrust level. Approximately 2 minutes remain in the Atlas booster phase of flight. The Atlas V rocket weighs now just 1/2 of what it did at launch, burning propellant at a rate of 2,600 pounds per second. Vehicle is now executing closed-loop steering. Centaur reaction control system is now pressurizing the flight levels.
So beautiful launch sequence there.
Atlas is 33 miles in altitude, 59 miles downrange distance, traveling at 5,600 miles per hour.
So Lucy being lifted up out of the atmosphere by the booster, getting on its way into a park orbit before we get towards...
All first stage vehicle systems are operating as expected at this time. The main engine is now throttling to maintain a constant 5G acceleration limit.
We're going to see a few things happen pretty rapidly. The booster will cut off just after 4 minutes, and then within the next 15 seconds after that, we should see the Atlas separate from the Centaur, and then the Centaur engine ignite for its first burn.
Centaur has begun the boost phase chill down sequence, and the RD-180 is now throttling to maintain a constant 4.6 G acceleration limit. Boost phase chill down sequence has completed, and we have BECO, booster engine cutoff, and a successful stage separation event. Preset on the RL-10, that's 1. We have ignition for the first burn.
All right, so there we go. We should see the fairing jettison here.
We have indication of good payload fairing jettison.
And there we go.
About an hour after the launch, Lucy separated from the second stage of the Atlas V. It then began to unfurl its 2 massive 7.3-metre wide solar arrays some 30 minutes later and began charging the spacecraft's batteries to power its subsystems. As they unfurled, each of the arrays should have locked into place, forming a disk. But only one of the disks provided confirmation of latching into position. NASA says the unlatched solar array is generating only slightly less power than expected when compared to the fully deployed wing, and it is enough to keep the spacecraft healthy and functioning. Still, mission managers have kept Lucy in safe mode since the partial deployment, running only essential functions. But the spacecraft has successfully transitioned into its cruise configuration. This mode increases autonomy of the space probe as it moves away from the Earth. NASA have also confirmed that Lucy was able to fire its thrusters to turn the spacecraft using the current solar array configuration. This solar array issue has forced NASA to postpone the deployment of the instrument platform, which contains the spacecraft's science payloads, including its cameras, a thermometer, and an infrared imaging spectrometer. Lucy's currently travelling at over 108,000 kilometres per hour on a trajectory that will orbit the Sun and bring it back towards the Earth in October 2022. That'll be the first of 3 gravity-assist flyby manoeuvres of the Earth. Over the next 12 years, these will slingshot the spacecraft, allowing it to rendezvous with and fly by 1 main-belt asteroid and 7 Trojans. That'll make Lucy the first spacecraft in history to explore so many different asteroids. The second gravity-assist flyby of the Earth in 2024 will send Lucy past the inner main belt asteroid 52246 Donald Johansen, which is named after the discoverer of the 3.2 million-year-old Australopithecus hominid fossil Lucy, which was found in Ethiopia in 1974. The spacecraft is named after the fossil because, like Lucy, which provided clues about the origins of early humans, the spacecraft will provide scientists with new clues about the origins of the solar system's planetary bodies. In 2027, Lucy will arrive at Lagrangian L4 Trojan cloud, which orbits about 60 degrees ahead of Jupiter as Jupiter orbits the Sun. There, it'll encounter 4 Trojan asteroids. Trojans are asteroids which orbit 60 degrees ahead and behind a planet as it orbits around the Sun. These locations are known as the L4 and L5 Lagrangian points. Lagrangian points are named in honour of Italian-French mathematician Joseph Louis Lagrange, who was working on the general three-body problem in orbital mechanics. He found that these were points in space where the gravitational pull of 2 bodies, such as say the Sun and the Earth, or the Earth and the Moon, tend to cancel each other out, while equaling the centripetal force needed for a small object to move relative to the 2 larger bodies, and so allowing the smaller object to remain in position for extended periods of time relative to those 2 larger bodies. There are 5 Lagrangian points, known as L1, 2, 3, 4 and 5. L1, 2 and 3 are all located along a single line connecting 2 bodies. Again, let's use the Earth and Sun as the example. L1 is between the Earth and Sun. It's often used by spacecraft needing uninterrupted views of the Sun, such as SOHO, the Solar and Heliospheric Observatory satellite. The L2 position is on the opposite side of the Earth to the Sun. It's home to the Planck spacecraft and will soon also be home to the James Webb Space Telescope. That's because it's ideal for astronomy, as spacecraft are close enough to communicate with the Earth and can keep the Sun, Earth and Moon behind the spacecraft for solar power while still providing a clear view of deep space for telescopes. The L3 position is located on the opposite side of the Sun to the Earth. And because the L3 point's always hidden from the Earth by the Sun, it's become popular in science fiction as the location of a hypothetical second Earth. And as we mentioned before, the L4 and L5 positions provide stable orbits around 60 degrees in front and behind a planet's orbit around the Sun. And that's where Jupiter's Trojan asteroids are located. After the L4 flybys, Lucy will swoop back past the Earth in 2031 for a third gravity assist. And that'll fling it to the L5 Trojan cloud, where it will intercept another asteroid in 2033. Now, technically, the 12-year mission will end following that interception. But at that point, Lucy will be in a stable 6-year orbit between the L4 and L5 clouds. And assuming the solar panel problem isn't too serious, a mission extension is possible. Lucy's scientific payload includes a panchromatic and colour visible imager and infrared spectroscopic mapper that'll be used to measure silicates, ices and organics on asteroid surfaces. There's also a high-resolution visible imager to provide the most detailed images of the surface of the Trojans, a thermal infrared spectrometer to study the characteristics of these asteroids, providing their composition and structure of surface material. And there's a radio science experiment to measure the mass of each asteroid using the spacecraft's radio telecommunications hardware and high-gain antenna to measure Doppler shifts. This report from NASA TV.
The Lucy mission is going to fly past 7 asteroids in 12 years with 1 spacecraft.
We are going to an amazing variety of objects with this mission. And it's really almost pure luck that allowed us to get as many rich targets as we are. Literally, the planets were aligning to allow us to do this mission.
The Lucy mission is named after the Lucy fossil, the Australopithecus fossil that was discovered in the 1970s in Ethiopia. And just like the Lucy fossil transformed our understanding of hominid evolution, the Lucy mission will transform our understanding of solar system evolution.
Trojan asteroids are an interesting population of small bodies that are left over from the formation of the planets, and they lead or follow Jupiter in its orbit by roughly 60 degrees. If you just look at the gravitational attraction of the Sun and Jupiter and put something exactly 60 degrees in front of Jupiter, it's stable forever. So as a result, these objects are really the leftovers of planet formation. The stuff that went into growing Jupiter and Saturn are now trapped in these locations.
The very first asteroid we get to is a main belt asteroid named Donald Johanson. We named that asteroid in honor of the researcher who found the Lucy fossil. We're going to use that asteroid to do a rehearsal on our spacecraft to make sure everything is working properly so that when we get to the Trojan asteroids, we're ready to go.
We're visiting both of the Trojan swarms. In the first orbit, we're going into the leading swarm, and we're going to encounter 4 Trojan targets.
Eurybates, Ptolemy, Lucas, and Oris. And from this, we're going to sample the diversity in sizes and colors and compositions. The first 2 flybys happen just about 30 days apart, so it's going to be a pretty busy kickoff to the season of exploring the asteroids in the L4 swarm. And then we'll fly past Earth again and out to the L5 swarm.
The final object we're visiting, which I must admit is my favorite, is a binary object.
So that's 2 Trojans that orbit a common center of mass. It's called Patroclus and Menecius.
These objects are nearly identical in size that orbit one another.
From the Lucy mission, we're going to study the diversity of our targets because that tells us something about their origin and where they came from.
The interesting thing about small bodies in general is they are the leftovers of planet formation. If you look at the 8 planets that we know about, for example, they are highly processed because of internal processing. These asteroids are objects that really haven't changed much from when the planets assembled themselves. And as a result, by studying them, we can figure out the physical conditions of the early solar system, as well as how the planets grew and how they moved around early on.
All of that will help us form a detailed picture of what these objects really look like. Because right now, our best images are just a point of light. Even using the Hubble Space Telescope or adaptive optics on large ground-based telescopes, we can't see surface details. And it's going to take the Lucy mission to go to these targets and see what they're really made of and what they look like.
And in that report from NASA TV, we heard from Lucy Principal Investigator Hal Leveson and Deputy Principal Investigator Kathy Alkin from the Southwest Research Institute in Boulder, Colorado. This is SpaceTime. Hey, don't forget you can help support our show by visiting the SpaceTime store for a huge range of promotional merchandising goodies. There's all sorts of things from jumpers and t-shirts through to caps and aprons. There are coffee mugs and stickers. There are coasters, neck chains, key rings, bags, and even water bottles. Just go to SpaceTime with Stuart Gary and click on the shop button. Still to come, a new study claims Venus never had any oceans, and China's Shenzhou 13 spacecraft successfully docks to Beijing's new space station. All that and more still to come on SpaceTime. Venus is often considered Earth's sister planet, but a new study claims that, unlike the Earth, Venus could never have had any oceans. It's all very puzzling because Venus and Earth are both the same size and mass. They were formed in the same part of the solar system, under similar conditions, and out of the same materials. Yet, while Earth is a habitable world where life thrives, Venus can only be described as a hell planet, with temperatures hot enough to melt lead, surface pressures 100 times higher than on Earth, a thick carbon dioxide atmosphere, and sulfuric acid rain. This, however, may not always have been the case. You see, previous studies have suggested that Venus may once have been a far more hospitable place, with its own liquid water oceans. However, this new study in the journal Nature claims atmospheric temperatures on Venus simply never got low enough for water in its atmosphere to condense to form raindrops, which could then fall onto the planet's surface. Instead, water remained as a gas in the atmosphere, and Venus's oceans never formed. The study's lead author, Martin Turbot from the University of Geneva, says the high temperatures meant that any water would have been present in the form of steam, sort of like a gigantic pressure cooker. The findings are based on sophisticated three-dimensional computer models of the Venusian atmosphere, similar to those used by scientists to simulate the Earth's current climate and future evolution. The authors studied how the atmospheres of the two planets would have evolved over the past 4.5 billion years, from the time when both worlds still had molten surfaces, and whether oceans could eventually have formed through this process. To form oceans, the temperatures of a planet's atmosphere would need to decrease enough for water to condense out of the atmosphere and fall as rain over a period of several thousand years. This is what happened on Earth. However, although we know the Sun was at least 30% fainter then than what it is now, this still would not have been sufficient to reduce early Venus's temperature to the point where oceans could form. Such a fall in temperature would only be possible if Venus's surface was shielded from solar radiation by a thick blanket of clouds. And that's where the problem lies. See, climate models show that the cloud cover would have preferentially formed on the night side of Venus, where they couldn't shield the surface from sunlight because that side's not receiving any. So instead of acting as a shield, those clouds help maintain high temperatures by causing a greenhouse effect, which trapped heat in the planet's dense atmosphere. Now, according to this climate model, the high surface temperatures prevented any rainfall, and as a result, the oceans on Venus were simply never able to form. Interestingly, the simulations revealed that the Earth could easily have suffered the same fate as Venus if the Earth had been just a little bit closer to the Sun, or if the Sun had shone as brightly in its youth as it does now. This is SpaceTime. If you want more SpaceTime, don't forget to check out our blog. There you'll find all the stuff which we can't fit in the show. There's loads of images, there are news stories, there are videos, and there's lots of stuff on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. Still to come, Beijing launches 3 Tigernautics on a mission to set a new Chinese space endurance record, and later in the science report, a new study has confirmed that 99.9% of peer-reviewed scientific papers agree that climate change is caused by human activity. All that and more still to come on SpaceTime. China's Shenzhou spacecraft has successfully docked with the Tianhe core module of Beijing's new space station. The mission was launched aboard a Long March 2F rocket from the Zhuquan Satellite Launch Center in northwestern China's Gobi Desert. The crew of 3 Taikonauts will spend the next 6 months aboard the orbiting outpost, setting a new Chinese space endurance record. During their stay, they'll undertake at least 3 spacewalks, and they'll continue setting up the space station and installing new equipment in preparation for expanding the orbiting outpost with the arrival over the next year of 2 additional modules. And that'll take the space station's overall mass to some 60 tons. This is SpaceTime. We designed SpaceTime to provide accurate and educational science news and information accessible to everyone. You can help support our work by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com and click on the Support SpaceTime button. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study in the journal Environmental Research Letters has found that over 99.9% of peer-reviewed scientific papers now agree that climate change is primarily being caused by human activity. The findings are based on a new survey of 88,125 climate-related studies. The new research updates a similar 2013 paper which showed that 97% of studies published between 1991 and 2012 supported the idea that human activities are altering Earth's climate. The new study by scientists from Cornell University examined the literature published from 2012 to November 2020 to explore whether the consensus had changed. Still, in spite of such scientific results, many public opinion polls, politicians and public commentators still believe there's a significant debate in the scientific community about the true cause of climate change. In fact, in 2016, the Pew Research Center found that only 27% of US adults believed that almost all scientists agreed that climate change was due to human activity. Scientists have discovered that a previously little understood mass extinction event rocked Africa and Arabia 33.9 million years ago. Previously, the Eocene-Oligocene mass extinction event was thought to have mostly only affected the oceans in what is now Europe and Asia. But a new report in the journal Communications Biology has found that nearly 63% of Afro-Arabian mammal species also went extinct during this event, which was apparently triggered by the Earth's climate shifting from swampy to icy. Scientists looked at fossils from 5 mammal groups, including a group of extinct carnivores called hyaenodonts, 2 rodent groups, including a scaly-tailed squirrel, and a group that includes porcupines and naked mole rats, and 2 primate groups, one including lemurs, the other apes and monkeys. Researchers were able to build evolutionary trees for these groups, pinpointing when new lineages branched out and time-stamping each species' first and last known appearances. Their results showed that all 5 mammalian groups suffered huge losses around the Eocene-Oligocene boundary. And then, over the next few million years, the surviving species diversified and began evolving into new species. Lockheed Martin's famous Skunk Works, which developed the famous U-2 spy plane, as well as the A-12 and SR-71 Blackbirds, have now unveiled the new super-long needle nose that will be mounted on the front of the new X-59 Quiet SST, or supersonic transport aircraft. Images released by officials at the usually top-secret Palmdale, California facility show the new nose positioned at the front of the aircraft, showing that it makes up almost a third of the aircraft's total length. The needle nose will essentially shape the supersonic shock waves during faster-than-sound flight. The idea being to quieten the usually loud sonic booms down to more acceptable sonic thumps, sufficiently at least to allow faster-than-sound flight over populated areas. Eventually, supersonic test flights will be undertaken by the new Quiet SST to gauge public reaction on the ground. One of the big problems with Concorde was that it was banned from flying supersonic over land because of the sonic boom, and was therefore only able to spread its wings on the transatlantic routes between New York and London and New York and Paris. Well, it's been a big week in tech, with new product launches by Apple, Google and Samsung. With the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
Yeah, well, Apple, Google, and Samsung all had product launches this week. We'll start with Apple first. They launched 2 new MacBook Pros, a 14-inch and a 16-inch, with new designs, including a little notch for the 1080p camera. But part of the bigger news was the M1 Pro chip, which was the expected upgrade to the existing M1 chip, which was revolutionary in that it used the ARM power, the chipset called ARM, the architecture, which is used in smartphones, and made it so that it could work in a laptop or desktop computer, and gave it so much power that it could run Intel code designed for Intel processors faster on an M1 than you could run on an Intel chip, and on top of that without a fan. Now, Apple launched the M1 Pro, which introduced more cores and just more of everything. And then they surprised by introducing something called the M1 Max, which was even bigger and better than the M1 Pro, and they did that in the same year. So they've taken what was already an incredible foundation and supercharged it further. They also launched a new AirPod 3. Looks very similar to the AirPod Pro. No active noise cancellation, but the shorter bud. I don't think you'll get the conversation boost. I think that's something that's only available on the AirPods Pro, as well as macOS 12 coming now as well, which will compete with Windows 11 and match the iOS 15, and the fact that Google also has Android 12, got new operating systems all over the place. Now with Google, they launched their new Google Pixel 6 and 6 Pro. Now the 6 Pro is the first smartphone in Australia that can do the mmWave version of 5G. That's the super fast version of 5G that can deliver way faster speeds. The current version of 5G that most people use is not much faster than 4G. But Telstra in a test is getting 3.6 gigabits. That's 3,600 megabits, or 36 times faster than what most people's NBN connections are. And Optus in a test got 4.5 gigabits, and in the lab they got 5 gigabits. Now, it's true to say that they would have had one or two people maximum using those connections at the time, and when you have tens, hundreds, thousands, or tens of thousands of people, the speeds will be slower. Yeah, you'll be slower, but hopefully we'll still be getting gigabit plus speeds. At the moment, if you get 500 megabits on 5G, on a non-mmWave 5G, you consider yourself lucky. And I know that in Canberra, there's a suburb where I had a Vodafone that could access 5G and I was getting 500 megabits, and I had a Telstra phone that was accessing 5G and I was getting 100 megabits. So, there are far fewer people in that area on Vodafone 5G. There's many more people on the Telstra. But nevertheless, Google's the first one to launch the mmWave 5G phone with the Pixel 6 Pro. The Pixel 6 doesn't have that. It's just regular 5G on that. But Google's got their own processor. They're learning from Apple. It's good to control and shape your own destiny with your own processor, and you can look after the priorities that are important to you, as opposed to Qualcomm, who has to try and make processors for everybody. The other big launch this week was Samsung, and Samsung has launched a new UI called One UI 4. So it's a refinement of all the previous operating systems I've had before, and it helps Samsung to differentiate its phone and make it better. They've extended that UI to their Samsung Watch 4. But the big news from Samsung is that with their Galaxy Flip 3, the Z Flip 3, you can now change the color panels on the outside with up to 49 different color combinations. And for example, Apple has for many years, they had the colorful iMacs, they had colorful iPod, and they had iPhone 5C in various colors. And so we've seen technology and fashion merge before. But Samsung's trying to take it an extra step further and give you 49 different choices. And so you can really customize the look of your phone to reflect you. And then what they said is that in the future, sometime presumably either later this year or early next year, you'll be able to change those colors again. So you can change the way your phone looks. And I guess it harks back to the old Nokia days when you could have different colored shells for the phones, and it was easy to take those shells off and put them on. The Galaxy Z Flip 3 Bespoke Edition is just a sign that technology has become such an integral part of our lives. It's now part of our fashion sense as well. And Samsung is trying to take advantage of that, and also promote the fact that it has the only mainstream folding phone that is fully up to date. And, whilst you might get a rectangular slab of glass and metal from Apple and Google and everybody else, Samsung's the only one that has the folding phone and the folding tablet.
I must admit, I do miss my old Motorola Razr from the olden days.
Yes, well, the Razr was an update to the StarTAC phone that they had, would have been in the 90s, and that was the first time they had that phone, which was very reminiscent of Captain Kirk's little communicator. That's right. And the flip phone was then copied by lots of different people. When the Razr came out, it wasn't obviously Razr thin, but it was a very thin design. I actually still have one of the Dolce & Gabbana branded golden ones. And the thing about those phones was the looks were just fantastic, but the operating system wasn't as powerful as Symbian at the time. And so it left something to be desired. It worked. You could make all the calls and text messages and MMSs.
Didn't matter. You opened it in a bar and everyone looked and said, cool.
Yes. Motorola did launch 3G versions of that phone with 3 mobile at the time, and you could make video calls. And then, of course, in more recent times in the last year, they did have the 4G and 5G versions of the Motorola phone with a very thin but actual folding screen, which was quite an impressive thing to see because, of course, the original Razrs had only the screen on the top and the bottom part was the keyboard. But with the Motorola folding phone, you had the full screen that popped out a bit like with the Samsung Galaxy Flip. But Samsung has arguably been a lot more successful with their flip phones and with their folding tablets. And it's something that is rumored for Google to launch next year, a Google Pixel Fold. People thought it might arrive with the launch of the 6 and 6 Pro, but it didn't. And of course, people are waiting to see when Apple might launch similar technology.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. and you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.